Yes, it is legal to use polyvinyl chloride, or PVC, conduits for feeder installations in residential buildings. The National Electrical Code, or NEC, allows the use of PVC conduits for branch circuits and feeders, provided they are installed in accordance with the code requirements. PVC conduits must be installed in accordance with the requirements of NEC Article 352. PVC conduits must be supported and protected from physical damage according to NEC Article 358. PVC conduits must be grounded, as per NEC Article 300.5. While PVC itself is not a conductor, it is possible to ground feeder installations in PVC conduits using the following methods. Metal bushings can be installed at each end of the PVC conduit where it connects to electrical boxes or enclosures. These bushings provide a ground path from the feeder to the electrical system. A separate grounding wire can be installed inside the PVC conduit to provide a ground path. To ensure compliance with electrical code requirements and safety standards, it is recommended to use PVC conduits with metal bushings or install a separate grounding wire inside the conduits for grounding purposes. Select PVC conduits with an appropriate temperature rating for the electrical installation. PVC conduits should be ultraviolet, or UV, resistant to prevent degradation from sunlight. Follow all NEC requirements and manufacturer's instructions for proper installation of PVC conduits. By following these guidelines, one can legally and safely use PVC conduits for feeder installations in modular homes. When using PVC conduit for electrical feeders, several factors must be considered to ensure a safe and compliant installation. Firstly, adherence to the National Electrical Code, or NEC, is paramount. The NEC provides comprehensive guidelines for electrical installations, including the use of PVC conduit. Specific articles, such as 352, govern the installation requirements for PVC conduit, addressing aspects like support, protection from physical damage, and proper connections. Secondly, grounding is a critical consideration. Although PVC is a non-conductive material, the electrical system within the conduit must be properly grounded to ensure safety and prevent electrical hazards. Grounding can be achieved through several methods, including the use of metal conduit bushings at each end of the PVC conduit, which provide a conductive path to the electrical boxes or enclosures. Alternatively, a separate grounding wire can be installed inside the PVC conduit to establish a dedicated ground path. Thirdly, the selection of appropriate PVC conduit is essential. The conduit must be rated for the intended electrical installation, considering factors such as temperature and exposure to ultraviolet radiation. Using UV-resistant PVC conduit is particularly important for outdoor applications to prevent degradation and ensure longevity. Fourthly, proper installation techniques are vital. Following the manufacturer's instructions and adhering to NEC guidelines will help ensure that the PVC conduit is installed correctly, providing adequate support and protection for the electrical feeders. Fifthly, local electrical codes and regulations should be consulted to ensure compliance with any specific requirements in the jurisdiction. These codes may supplement the NEC and provide additional guidance for electrical installations. By addressing these considerations, electrical professionals can safely and legally use PVC conduit for feeder installations, providing reliable and protected pathways for electrical conductors. The key is to ensure that grounding is properly addressed, the correct type of PVC is selected, and all relevant codes and regulations are followed. Furthermore, it is important to consider the specific application and environment in which the PVC conduit will be installed. For example, in areas with extreme temperatures or exposure to corrosive substances, specialized PVC conduit may be required to withstand these conditions. In addition to grounding and material selection, proper sizing of the PVC conduit is also important. The conduit must be large enough to accommodate the electrical conductors without overcrowding, which can lead to overheating and potential hazards. The NEC provides guidelines for conduit fill, specifying the maximum number and size of conductors that can be installed at a particular size of conduit. When installing PVC conduit, it is also crucial to use appropriate fittings and connectors. These fittings should be designed for use with PVC conduit and should provide a secure and watertight connection. Using the correct fittings will help prevent moisture from entering the conduit, which can damage the electrical conductors and create a safety hazard. Regular inspections and maintenance of PVC conduit installations are also recommended to identify and address any potential problems early on. This includes checking for cracks, damage, or loose connections, as well as ensuring that the grounding system remains intact. By following these best practices, electrical professionals can ensure that PVC conduit installations are safe, reliable, and compliant with all applicable codes and regulations. Additionally, it is beneficial to stay informed about any updates or changes to the NEC and other relevant standards, as these can impact the way PVC conduit is installed and used. Continuous learning and professional development are essential for staying up to date with the latest advancements and best practices in the electrical industry. Moreover, consider the long-term durability and maintenance requirements of PVC conduit installations. While PVC is generally resistant to corrosion and degradation, it can be susceptible to damage from physical impacts or exposure to certain chemicals. Taking steps to protect the conduit from these potential hazards can help extend its lifespan and reduce the need for costly repairs or replacements. This might include using protective covers or barriers in areas where the conduit is at risk of being damaged, or selecting a more robust type of conduit for demanding environments. Furthermore, proper labeling and documentation of PVC conduit installations are important for future maintenance and troubleshooting. Clearly labeling the conduit runs and documenting their locations can save time and effort when performing repairs or modifications to the electrical system. This information can also be valuable for facility managers and other personnel who may need to access or work around the conduit in the future. In addition to the technical aspects of PVC conduit installations, it is also important to consider the environmental impact of using PVC materials. While PVC is a versatile and cost-effective material, it is derived from petroleum and can pose environmental concerns related to its production and disposal. Exploring alternative materials or practices that reduce the environmental footprint of electrical installations can be a responsible and sustainable approach. This might include using recycled materials, optimizing conduit layouts to minimize material usage, or implementing energy-efficient wiring methods. Furthermore, it is important to be aware of any potential health hazards associated with working with PVC conduit, such as exposure to dust or fumes during cutting or installation. Following proper safety precautions, such as wearing appropriate personal protective equipment and ensuring adequate ventilation, can help minimize these risks. Finally, it is essential to foster a culture of safety and compliance among all personnel involved in PVC conduit installations. This includes providing comprehensive training, conducting regular safety audits, and encouraging open communication about potential hazards or concerns. By prioritizing safety and adhering to established codes and regulations, electrical professionals can help prevent accidents, injuries, and property damage. The selection of PVC conduit size is crucial for safe and efficient electrical installations. The conduit size must accommodate the number and size of conductors while adhering to the National Electrical Code or NEC guidelines for conduit fill. Overfilling a conduit can lead to overheating, insulation damage, and potential electrical hazards. NEC Chapter 9, Table 1 specifies the maximum percentage of conduit area that can be occupied by conductors. This percentage varies depending on the number of conductors in the conduit. For example, for 3 or more conductors, the maximum fill is typically 40%. To determine the appropriate conduit size, electrical professionals should consult NEC Chapter 9 Tables 4 and 5, which provide the dimensions and cross-sectional area of various types of conductors. By calculating the total cross-sectional area of the conductors and comparing it to the allowable fill area of different conduit sizes, the correct conduit size can be selected. It is important to consider the conductor's insulation type when determining its cross-sectional area. Different insulation types have different thicknesses, which can affect the overall size of the conductor. In addition to conductor fill, it is also important to consider the bending radius of the conduit. Sharp bends can damage the conductors and make it difficult to pull them through the conduit. The NEC specifies minimum bending radii for different conduit sizes and materials. When making bends in PVC conduit, it is important to use appropriate bending equipment and techniques. The conduit should be heated evenly to prevent kinking or cracking. After bending, the conduit should be allowed to cool before being installed. Proper support of PVC conduit is also essential for ensuring its structural integrity and preventing damage to the conductors. The NEC specifies the maximum spacing between supports for different conduit sizes and materials. Support should be securely fastened to the building structure and should be designed to withstand the weight of the conduit and conductors. In addition to physical support, it is also important to protect PVC conduit from physical damage. Conduit should be installed in locations where it is not likely to be struck or damaged by equipment or vehicles. If conduit is installed in an exposed location, it should be protected by a barrier or guard. When installing PVC conduit underground, it is important to follow the NEC guidelines for burial depth. The minimum burial depth varies depending on the voltage of the conductors and the type of location. Underground conduit should be installed in a trench that is free of rocks and other debris that could damage the conduit. The trench should be backfilled with suitable material such as sand or gravel and compacted to provide support for the conduit. Proper grounding of PVC conduit systems is essential for safety and compliance with the NEC. While PVC is a non-conductive material, the metal components of the electrical system, such as junction boxes and enclosures, must be properly grounded. Grounding can be achieved by bonding the metal components to a grounding electrode system, such as a ground rod or water pipe. The grounding conductor should be sized in accordance with NEC Table 250.122, based on the size of the circuit conductors. In addition to grounding the metal components, it is also important to ensure that the PVC conduit itself is properly bonded. This can be achieved by installing a bonding jumper between the conduit and the metal components. The bonding jumper should be sized in accordance with NEC Table 250.102. When working with PVC conduit, it is important to follow all safety precautions. PVC conduit can release harmful fumes when heated or burned. Therefore, it is important to work in a well-ventilated area and to wear appropriate respiratory protection when cutting or heating PVC conduit. PVC conduit can also become brittle in cold weather. Therefore, it is important to handle PVC conduit carefully in cold temperatures to prevent it from cracking or breaking. By following these guidelines, electrical professionals can ensure that PVC conduit systems are installed safely, efficiently, and in compliance with the NEC. Continuous training and education are essential for staying up to date with the latest codes and best practices in the electrical industry. The NEC is updated every 3 years, so it is important to stay informed of any changes or revisions that may affect PVC conduit installations. Additionally, attending industry conferences and workshops can provide valuable opportunities to learn from experts and network with other professionals in the field. Remember that the selection of fittings and connectors is a critical aspect of PVC conduit installations. Using the correct fittings ensures a secure, watertight, and code-compliant system. There are several types of PVC fittings available, each designed for specific applications. Firstly, couplings are used to join two sections of PVC conduit together. They are available in both rigid and expansion types. Rigid couplings provide a fixed connection, while expansion couplings allow for thermal expansion and contraction of the conduit. Secondly, elbows are used to change the direction of a conduit run. They are available in various angles, such as 45 degrees and 90 degrees. Thirdly, T's are used to create a branch in a conduit run. They have 3 openings, allowing conduit to be connected in 3 different directions. Fourthly, adapters are used to connect PVC conduit to other types of conduit or equipment. They are available with various thread types and sizes. Fifthly, connectors are used to terminate conduit at boxes or enclosures. They provide a secure and watertight connection. When selecting PVC fittings, it is important to consider the following factors. Firstly, the size of the conduit. The fitting must be compatible with the size of the conduit being used. Secondly, the type of application. The fitting must be designed for the specific application, such as above ground, underground, or wet locations. Thirdly, the environmental conditions. The fitting must be resistant to corrosion, ultraviolet radiation, and other environmental factors. Fourthly, the code requirements. The fitting must comply with all applicable codes and standards such as the National Electrical Code, or NEC. When installing PVC fittings, it is important to follow the manufacturer's instructions. This will help ensure a secure and watertight connection. The following steps are typically involved in installing PVC fittings. Firstly, cut the conduit to the desired length. Secondly, deburr the ends of the conduit. Thirdly, apply PVC cement to the inside of the fitting and the outside of the conduit. Fourthly, insert the conduit into the fitting and twist to distribute the cement. Fifthly, hold the conduit and fitting together for a few seconds until the cement sets. Sixthly, wipe off any excess cement. Proper installation of PVC fittings is essential for ensuring the safety and reliability of the electrical system. By following the manufacturer's instructions and considering the factors mentioned above, electrical professionals can ensure that PVC fittings are installed correctly and provide a long-lasting, trouble-free connection. Additionally, regular inspection and maintenance of PVC fittings can help identify and prevent potential problems. This includes checking for cracks, leaks, and loose connections. Any damaged or worn fitting should be replaced immediately. Also, consider the impact of temperature variations on PVC conduit systems. PVC expands and contracts with temperature changes, which can put stress on the conduit and fittings. To accommodate this expansion and contraction, expansion couplings should be used in long conduit runs or in areas with significant temperature fluctuations. Expansion couplings allow the conduit to move without putting stress on the connections. The amount of expansion and contraction depends on the length of the conduit run, the temperature change, and the coefficient of thermal expansion of PVC. The manufacturer's instructions for the expansion coupling should be followed to ensure proper installation and operation. In addition to expansion couplings, expansion joints can also be used to accommodate movement in PVC conduit systems. Expansion joints are typically used in underground applications where the conduit is subject to soil movement or settlement. They provide a flexible connection that can absorb movement without damaging the conduit. Proper selection and installation of expansion couplings and joints are essential for maintaining the integrity of PVC conduit systems in areas with temperature variations or soil movement. Ignoring these factors can lead to conduit damage, leaks, and potential electrical hazards. When working with PVC conduit, it is also important to be aware of the potential for static electricity buildup. PVC is a non-conductive material, which means that it can accumulate static electricity. This can be a concern in environments where flammable materials are present. To prevent static electricity buildup, anti-static coatings can be applied to the PVC conduit. These coatings help dissipate static electricity and reduce the risk of ignition. In addition to anti-static coatings, grounding straps can also be used to ground the PVC conduit. Grounding straps provide a conductive path for static electricity to discharge, preventing it from accumulating on the conduit. Proper grounding of PVC conduit is especially important in hazardous locations where flammable materials are present. By taking these precautions, electrical professionals can minimize the risk of static electricity buildup and ensure a safe working environment. Remember that proper labeling of PVC conduit systems is an important aspect of electrical safety and maintenance. Labeling helps identify the purpose and voltage of the conductors within the conduit, making it easier for electricians and other personnel to work on the electrical system safely. Labels should be durable, weather-resistant, and securely attached to the conduit. They should also be easy to read and understand. The National Electrical Code, or NEC, requires that all electrical circuits and equipment be properly labeled. This includes labeling of conduit, junction boxes, and other enclosures. The labeling requirements vary depending on the voltage and type of circuit. In general, labels should include the following information. Firstly, the circuit number or identifier. Secondly, the voltage of the circuit. Thirdly, the purpose of the circuit. Fourthly, the location of the circuit's overcurrent protection device. Labels should be placed at regular intervals along the conduit run, as well as at all junction boxes and enclosures. This ensures that the information is readily available to anyone working on the electrical system. In addition to standard labels, color coding can also be used to identify different types of circuits. For example, different colors can be used to indicate the voltage level or the type of load being served. Color coding can be a helpful way to quickly identify circuits, but it is important to use a consistent color coding scheme throughout the electrical system. Proper labeling of PVC conduit systems is essential for preventing electrical accidents and ensuring the safety of personnel. By following the NEC requirements and using clear, durable labels, electrical professionals can create a safe and well-organized electrical system. Continuous education and training are vital for electrical professionals to stay up to date with the latest codes, standards, and best practices in the industry. The electrical industry is constantly evolving, with new technologies and regulations being introduced on a regular basis. To remain competent and provide safe and reliable electrical services, electrical professionals must commit to ongoing learning and development. There are several ways for electrical professionals to stay current with the latest developments in the industry. Firstly, attending industry conferences and trade shows. These events provide opportunities to learn from experts, network with peers, and see the latest products and technologies. Secondly, reading industry publications and websites. There are many excellent magazines, journals, and websites that cover the electrical industry. These resources can provide valuable information on new codes, standards, and best practices. Thirdly, taking continuing education courses. Many organizations offer continuing education courses for electrical professionals. These courses can cover a wide range of topics such as the National Electrical Code, or NEC, electrical safety, and new technologies. Fourthly, participating in professional organizations. Professional organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA, offer valuable resources and networking opportunities for electrical professionals. Continuous education and training are not only important for maintaining competence, but also for advancing one's career. Many employers require or encourage their employees to participate in continuing education activities. By investing in their own professional development, electrical professionals can increase their earning potential and improve their career prospects. Moreover, bear in mind the importance of proper documentation and record keeping for PVC conduit installations. Accurate and complete documentation is essential for ensuring the safety, reliability, and maintainability of electrical systems. Documentation should include detailed information about the design, installation, and testing of the PVC conduit system. This information can be used for future troubleshooting, repairs, and upgrades. The following types of documentation should be maintained for PVC conduit installations. Firstly, as-built drawings. As-built drawings show the exact location of all conduit runs, junction boxes, and other components. These drawings should be updated to reflect any changes made during the installation process. Secondly, equipment specifications. Equipment specifications provide detailed information about the materials and components used in the PVC conduit system. This includes the type and size of conduit, fittings, and connectors. Thirdly, test reports. Test reports document the results of all testing performed on the PVC conduit system. This includes continuity testing, insulation resistance testing, and ground impedance testing. Fourthly, maintenance records. Maintenance records document all maintenance activities performed on the PVC conduit system. This includes inspections, repairs, and replacements. All documentation should be stored in a safe and accessible location. It should also be organized in a way that makes it easy to find the information needed. Proper documentation and record keeping are essential for ensuring the long-term performance and reliability of PVC conduit systems. By maintaining accurate and complete records, electrical professionals can help prevent electrical accidents and ensure the safety of personnel. Finally, consider the importance of sustainability and environmental responsibility when working with PVC conduit. PVC is a versatile and durable material, but it is also a petroleum-based product. As such, it has a significant environmental impact. To minimize the environmental impact of PVC conduit installations, electrical professionals should consider the following strategies. Firstly, using recycled PVC. Recycled PVC is made from post-consumer or post-industrial waste. It has the same performance characteristics as virgin PVC, but it has a lower environmental footprint. Secondly, reducing waste. Waste can be reduced by carefully planning the installation and using only the amount of conduit needed. Cut-offs and scrap should be recycled whenever possible. Thirdly, using energy-efficient installation practices. Energy-efficient installation practices can help reduce the environmental impact of PVC conduit installations. For example, using hand tools instead of power tools can save energy. Fourthly, disposing of PVC properly. PVC should be disposed of properly at the end of its useful life. It should not be burned or buried in landfills. Instead, it should be recycled or disposed of at a hazardous waste facility. By adopting sustainable and environmentally responsible practices, electrical professionals can help minimize the environmental impact of PVC conduit installations. This is not only good for the environment, but it can also enhance the reputation of the electrical contractor and attract environmentally conscious customers. The selection of appropriate tools and equipment is paramount for efficient and safe PVC conduit installations. Using the right tools not only streamlines the installation process but also minimizes the risk of damage to the conduit and ensures a secure and reliable electrical system. Firstly, a PVC cutter is essential for making clean and accurate cuts. There are various types of PVC cutters available, including ratchet cutters, scissor cutters, and saw cutters. The choice of cutter depends on the size and thickness of the conduit being cut. Secondly, a PVC heater or bending tool is necessary for bending conduit to the desired angles. PVC heaters use hot air to soften the conduit, allowing it to be bent without cracking or kinking. Bending tools provide a more controlled and precise bending process. Thirdly, a deburring tool is used to remove any sharp edges or burrs from the cut ends of the conduit. Deburring ensures a smooth surface for connecting fittings and prevents damage to the conductors. Fourthly, a PVC cement applicator is needed for applying PVC cement to the conduit and fittings. The applicator should provide consistent and even coating of cement to ensure a strong and watertight bond. Fifthly, a level is used to ensure that the conduit runs are straight and level. A level is particularly important for long conduit runs and for installations where aesthetics are a concern. Sixthly, a measuring tape or ruler is essential for accurately measuring and marking the conduit. Accurate measurements are crucial for ensuring that the conduit fits properly and that the electrical system meets code requirements. Seventhly, a drill and drill bits are used for drilling holes in the conduit for mounting or for pulling wires. The drill bit should be sized appropriately for the holes being drilled. Eighthly, a screwdriver or nut driver is used for tightening screws and nuts on fittings and connectors. The screwdriver or nut driver should be sized appropriately for the fasteners being used. Ninthly, safety glasses and gloves are essential for protecting the eyes and hands from debris and chemicals. PVC cement can be irritating to the skin and eyes, so it is important to wear appropriate protective gear. Tenthly, a wire puller or fish tape is used for pulling wires through the conduit. The wire puller should be sized appropriately for the size and number of wires being pulled. By using the right tools and equipment, electrical professionals can ensure that PVC conduit installations are performed efficiently, safely, and in compliance with code requirements. Regular maintenance and inspection of tools and equipment are also important for ensuring their proper functioning and preventing accidents.